Hello learners, this session we are going to see how we can able to practically implement the static algorithms adapted in your load balancing concept. We will incorporate all the necessary libraries to your code. So once you have been imported all the necessary libraries in a Prosim environment, we are going to have the virtual machine list as well as load list parameters declared. And moving on to the main instructions, we have number of users to be assigned is now, and we have the time value to be taken up as calendar.get instance method, and we have the trace flag which is going to be false. As it is going to be this application, we are making it as a false. So these are the three important parameters that are supposed to be to initiate your CloudSIM environment. So cloud.init is just going to pass the users with the calendar and trace flag to be passed to your init method. So once you have been initiated a CloudSIM environment, you are supposed to have your data center specifications. In order to have your data center specifications, we are going to invoke the method of create data center method, passing the name for that data center. So when you are going to invoke the create data center method, it calls the notifications over here. So we are just going to have the host specifications. Okay, like million instructions per second is going to be 1000, RAM is going to be 2048, and storage is going to be 1 MB, and bandwidth is going to be 10,000. So we are going to utilize these specifications for having the processing element to be adopted. So for your processing element, we have the processing element provision is simple, which is going to have the bandwidth. Not only bandwidth, we have the virtual machine as well as your storage RAM provisioner. Simple is also going to be adapted to this list. So we have three hosts of these particular specifications that are declared in your data center environment. So what is your data center environment? The data center environment has additional features of the architecture. System architecture is going to be x86, and the OS is going to be Linux, and we have virtual machine monitor is going to be 10 Zen. The time Zen is with 10. Cost, which is going to be 3. Cost per memory is going to be 0.05. Cost per storage is going to be 0.001, and cost per bandwidth is going to be 0.0. So these are the peculiar features which we are adapted for your data center. We have the storage list that has been adapted in a linked list environment. The characteristics for the particular data center that evolves in following the architecture, OS, VMM, host list, time zone, and the cost for all the resources. We have been declared as a characteristics for a particular data center. So once you have the peculiar features for your data center, we are just going to create it as a new data center. So new data center is going to be the name which has been passed and which has the additional characteristics like what is the architecture, what is the OS, what is the VMM, and what are the various time zone or the cost per session, and what virtual machine policy which has been adopted. So here we have the timestamp time shared as the policy that has been adopted. So this is the peculiar statement which have been raised out for in order to create a data center. So once you have been created a data center, you are supposed to create a broker. Okay, so create a broker in terms of data center broker, passing the broker name. Okay, so this broker doing your virtual machines as well as your cloudlets, the job or the task which has been assigned to each and every virtual machine. So creating a broker using the broker ID. So we're just going to have data center broker with broker name, which can able to have for each and every broker. We are just going to have an ID of it. Get ID. This can able to be utilized for each and every virtual machines or to the cloudlets. So the next stage is going to be the virtual machines creation. Virtual machine using broker ID, and we're just going to have how many machines we are going to adopt it. We are just these two information for a creation of a virtual. So in order to have the creations, we're just invoking create VM. So create VMs is going to have specifications of each and every virtual machine. Each 5 virtual machines is using these specifications. Per second is going to be 1000, size is going to be 1 MB, and RAM is going to be 50, and bandwidth is going to be 1000, and we have number of is going to be 1 and VM is going to be 0. So we are just going to have the specification in order to have the virtual machines. So we are going to pass this for each and every virtual machine. We have the specifications given to this, and we are identifying the broker ID which has been passed to it. Okay, so we are going to have the number of virtual machines which has been passed to it is 5. So we are creating 5 virtual machines under this particular application. So once you have been created a virtual machines, we are just going to create the cloudlets of it. So before creating the cloudlets of it, we are submitting the virtual machine list to the broker. As we said that the broker is going to be the coordinator between the virtual machine as well as the cloudlet. We are just going to have the linkage between the virtual machine to the cloudlet using this submit VM list. Next step is going to creation of cloudlets. We are just going to assign the number of tasks. Okay, we are just going to create the number of tasks. So create cloudlets in terms of the broker ID and to the cloudlets. So we are going to have this create cloudlet. Create cloudlets will be invoked. So when you're going to have the create cloudlet, we are going to have the each and every task that has been assigned. We are just going to have it in terms of their specifications. That is, what is the length, what is my file size, what is my output size, and how many processing elements will be there, and what is the model, utilization model will be. So here we have the utilization model will be full, which means that we have the CPU, RAM, as well as the bandwidth. We are going to utilize it in the utilization model method. Okay, we are going to have 10 cloudlets. We are going to have 10 cloudlets that have been created using the specifications, given specifications. So once you have been created the cloudlets, so these cloudlets is also have to be assigned to your broker using submit cloudlet list. So broker.submit cloudlet list is going to link to the broker. Okay, now we can able to have the various algorithms that you can able to adopt it. The first one is a round robin virtual machine allocation passing the broker, or can able to have a random virtual machine allocation through broker, and the throttled virtual machine allocation. So these are the 3 ways you can able to have the algorithms to be adapted for your multiple tasks that has been assigned to your virtual machines. So here, first round robin fashion, which you have been seen to invoke. We are passing the broker. For a broker, we have a not only cloudlet list, we have the virtual machine list. We are taking those 2 factors and we are going to bind cloudlet to virtual machine. So dot cloudlet to virtual machine is we are just going to have the resources to be accompanied. Here the resources is going to be the virtual machine. The task is the cloudlet. For each and every cloudlet, we are just going to assign it to the virtual machine. So using get cloudlet ID as well as get virtual machine ID, we are just going to pass this or bind this, and the method which has been invoked is the round robin method, where initially it starts with the first virtual machine, then the second virtual machine, it moves on in a round robin way, circular way. So this is the way where we have been located in a round robin virtual machine application. And the second method is going to be the random virtual machine application, where we are just going to have the method of rand next int, which have the random value that has been taken up to have the binding of your cloudlet to your virtual machine. So using this, we are just going to generate the virtual machines randomly and assign it to the cloudlet. So this is a random load balancing. So this has been rarely used. And the next method which has been accompanied is a throttled virtual machine allocation, where we are just going to have the condition to be checked whether which virtual machine is busy or free. If it is going to be busy, we are just going to have the next virtual machine to be used. So we are not going to identify the next virtual machine, and we are just going to check whether it is free or not. Okay, whether it is busy or not. If it is going to be busy, we are just going to identify the next one. Okay, once it has been not free, the virtual machine is being free, we are just going to get the index of it and bind it to the particular cloudlet, particular task. Okay, here we are checking that each and every virtual machine whether it is busy or free. If it is busy, we are just going to the next virtual machine which have to be allotted. If not, we are going to assign it to the task which have been used. So here we are ensuring the virtual machine to be we are ensuring that all the virtual machines has been equally distributed, that is it is not been overloaded. Okay, so once you have been completed all the tasks, you can able to remove your uh, cloud virtual machines which can able to make it freeze, that is it can able to free that particular virtual machine in order to utilize it for the upcoming task. So that dot remove is going to remove the particular virtual machines in order to make it to the next task. Okay. So this is going to be availed in order to use it for the upcoming resources to be used. So this is where the throttled virtual machine allocation has been done. So in a throttled virtual machine allocation, we are checking whether the virtual machine is being busy or free. So on ensuring it has been loaded already, we are going for the other virtual machine. If not, we are just going to utilize it. Okay, so we are checking for the particular virtual machines whether it is free or not. So once you have been accompanied each and every virtual machine, each and every cloudlet to the virtual machines, we are just going for the task of starting the simulation part. So cloud.start simulation. Once you have simulated your results, you can able to get it in a get cloudlet receive list. So this can able to ensure the resultant that have been taken up from the simulation part, then stop the simulation in a closed sim environment. Then print the results. So from printing the results, we are just going to ensure the cloudlet ID, the status of it, and what is the data center ID, the virtual machine ID, and the actual CPU time, execution start time, as well as the finish time. So these are the features that we can able to note it out upon receiving the cloudlet details on simulation part. So once executing this code, so this is going to be throttled, which means that we are ensuring that for each and every virtual machine, if it is going to be free, virtual machine is free, we are allowing the task to be executed. If not, we are just going to accompany it. So here it seems like similar to a round robin. So cloudlet 0 utilizes the data center ID. So cloudlet 1 it uses virtual machine ID 1, and cloudlet 2 which uses the virtual machine ID 2. So in a round robin fashion, which means that machine is free, we are realizing. In this way, we have to adopt the of algorithm in a load